What's going on, guys? So in this video, we're going to be going over how to use knowledge graphs to help your LLMs better answer questions about your business. And if you don't know what knowledge graphs are, this is a knowledge graph, okay? Knowledge graphs is an easy way to represent interactions of different entities of data. So the example we're going to be using in this video is client contracts, okay? So imagine you're a marketing agency. You have, let's say, 10 clients. Each client has 3 different contracts, like a service agreement, NDA, and like a statement of work or some shit like that, right? And this is the knowledge graph I built out. I'm gonna be diving in how I actually built this. You can see for, say, Orion Ventures, which is a made-up company, by the way, right? It's able to map out which services we're offering to this company. So PPC, SEO, campaign strategy, digital marketing services, and you can also see Echo Core Systems, this other company right here. We're also offering similar things, which is digital marketing. Essentially, what this knowledge graph allows us to do, it allows us to map out how our different contracts interact with one another, like which contracts have different clauses, like which ones are we offering SEO, which ones have an NDA clause, right? Or which contracts did we sign in last year of 2024, which didn't, things like that. It allows us to examine the whole broad scope of our contract space and how they interact with one another. And this doesn't just apply to contracts as well. This can apply to like the work that your fulfillment for your clients, right? Let's say you have different clients, right? You guys have different services for each client. And also you have different due dates for different deadlines for each client, right? Say for client A, their cold email campaign is supposed to launch next week. The other client B, their emails campaign is supposed to be launched in 2 weeks. Their evaluations are due in a month. I don't know. These knowledge graphs allow you to essentially like examine all your entities across the board. So they could be client work, just client contracts, whatever you want really, and see how they interact with one another. And we're allowed to take the information in this knowledge graph, you'll see in a second, and actually put that into an LLM to better answer questions about our business. Before we get into actually how I built this, I'm just gonna give you guys a quick demo of this chatbot that I built out using this knowledge graph. So this same knowledge graph right here, what's gonna happen is when we ask it a question, it's gonna find the exact data from all this right here, okay, to put into the LLM, and you guys will see how it works in a second, and then to help answer the question. So let's just say which customers or which clients do we do SEO work for? And I built something similar to this in the past with a contract agent, but how we did it then was we had to go manually identify like which contracts we had to go through. We opened up every contract and we had to manually check for each and every single contract, does this have SEO? Versus with a knowledge graph, we're able to get this data just from how the nodes interact with one another. What I will say, there's no right or wrong answer on which is best. I will say like this approach is much faster, but may lead to more unreliable results. And the other route with this going through each contract individually will take much longer, but will get you much more accurate answers. So just depends on the scenario and what you're looking for and the type of accuracy you're looking for in your AI system. But as you can see here, it gets the actual answer. So we do this SEO work for the following clients: Orion Ventures, Brightline Robotics, Solar Nova, Ecosystem, and Vertex Labs. And it's able to get the information to properly answer this question from looking through all the nodes and how they interact with one another, specifically the nodes labeled with SEO on it. Just to give you guys a definition of how knowledge graphs work, knowledge graphs are a way to capture connections between things like people on LinkedIn, or in our case, contracts, clauses, dates, and services. Instead of just writing this information in a knowledge base or document, the graph allows us, so again, how those nodes connect, or the network, whatever you want to call it. The graph lets us see how everything is linked. Which contracts include SEO, which contracts have a confidentiality clause, which end after July, shit like that, right? It turns scattered facts into like a connected web, so we can ask smarter questions that are like about different contracts across the board and how they connect with each other. Instantly find patterns across all of our contracts, okay? And we'll get into this shit later. First thing you're gonna need is your contract PDFs, okay? So for us, we just use the markdown files just to make things easier. So these are like random companies I built within GPT. But yeah, so NDAs, statement of work, master service agreement. Notice how in each of these markdown files, we actually provided good headers for each of the titles. That way, when we chunk everything, so it's easy to grab the actual section title to give the LLM more context and split everything up cleanly by section. Next thing is contracts metadata. So that's just gonna be like a CSV file of just like the file name, so all these file names, the company name that corresponds with it, and the contract type. So master service agreement, NDA, statement of work. And the last thing we need is our ontology file. And I'm gonna show you guys how that works in a second, because that's probably new to you guys. What an ontology file is, it's defining the way that we wanna connect different entities between our contracts, okay? So entities are like, so these would be like nodes, quote unquote, inside the actual knowledge graph. So that'd be like, say, the client name, the service that we're offering, like the jurisdiction of where the contract resides in. But yeah, and then the next thing we want to define too after entities is the relationship. So what potential relationships can exist between these entities? So for example, from client to contract, there could be a relationship. So what we're defining here is, so in relationships, we're going to call it signs, right? That's the name of this relationship, from client to contract. So what does that mean? When a client signs a contract, that is the name of that relationship. So that type of arrow, that type of edge could exist in our knowledge graph, which is what it shows right here, based off our definition of relationships. So what we're gonna do is this is gonna be like almost the directions when we give it to GPT to help define how to connect what to what. Okay, so when we're saying the name of the relationship is signs and from client to contract, we're saying that a relationship can exist from the client, so Vertex Labs, right? This is the client name right here, and it can sign a contract called Vertex Labs _ statement of work, so the statement of work agreement, right? And that we allow this to exist essentially. So again, we're just defining what type of relationships can exist in this knowledge graph. So issued by, so from the contract to a company, or has clause, so it has this type of clause, and pertains to, and you get the idea, right? And what we can then do is to help the LLM get more data, because again, with LLMs, you want to forget knowledge graphs, just with LLMs as a whole, you want to supplement it with examples always. So here are types of contracts, right? Like master service agreements, statement of work, NDAs, right? Type of clauses, so termination, renewal, confidentiality, payment, scope. What type of services, what type of example services are there? Facebook ads, Google ads, X, Y, and Z, and jurisdiction, right? We want to give it more context to help the LLM best understand the interactions between the contracts with one another, okay? But yeah, guys, that's pretty much how an ontology file is usually structured. After we have all that, we're going to chunk the PDFs by section, okay? And you're going to understand in a second why. So again, this is just a PDF, or this is a markdown file. We're going to chunk each of them by its section. So the purpose of this NDA file, we're going to give it the actual header of the contract, right? And give it the actual section title. So NDA, purpose, this. NDA, confidential information, and then the actual clause that comes with it. That way, when we provide a chunk for this, it has the full amount of data. So NDA, what section within the NDA contract, and the actual clause that corresponds with this. And this can apply with everything else as well, like services to be provided. So as part of the statement of work contract, this is under the services to be provided section, and here is our services to be provided. That way, when we give this chunk to an LLM, it understands what this set of text is supposed to be about. After we chunk the PDFs, we take the contract, we take the chunks, we take the contracts metadata, we take the ontology file, and we extract structured triplets using LLMs. And I'm going to explain what that means, because that's obviously very fucking confusing. So in our ontology file, right, we listed all these entities and all these potential relationships. What we need to do is give the LLM each chunk. So let's just say this little piece right here, right? We're going to give it this piece and say what potential relationships, based off the ones we defined in our ontology file, exist in this chunk of text. Okay, and we're just gonna give that to GPT. All right, and what's gonna happen is, so an example of a triplet, when a client signs a contract is Brightline Robotics. Okay, that's the client. They signs that the relationship that we defined, the relationship that we allowed to be defined in our ontology file, right? Back over here, right? Signs this contract, Brightline Robotics statement of work.md, and this is just like how we showed it in the knowledge graph with Vertex Labs. Vertex Labs, right, signs right here this statement of work file, this markdown file. And here's some other examples with jurisdiction, service inclusion, and context and contract duration. Okay. And again, all we're doing with an LLM here, and I'm going to show you guys the prompt in a second, is extracting the potential relationships from each chunk that we already defined. Remember, we defined these relationships in the ontology file, right? Here's the potential entities. Here's the potential relationships that can exist. Here's the LLM, and you give these relationships to the LLM and say, do any of these exist in this piece of text, okay? And then once we extract all these triplets from across all of our contracts, right? Because once we extract all these triplets, we now have all the data on the type of relationships our contracts have that we already defined under relationships with our ontology file. Again, I just want to keep reiterating this, because yeah, once we're done with that, all we have to do is just push it to the graph database. The one I use, I think everyone uses, is Neo4j. Right? So I just pushed it up to that. You can just use it through their API. And yeah, once we have this, we now have our data ingested. We have a way to understand how our contracts interact with one another. And now after we do this, we can build the actual RAG or the chatbot setup for all this. So how the flow works is the user asks a question, just like any chatbot, right? Like what clients do we do SEO work for? Which contracts end after July 15th, 2025? Once the user asks a question, what we're going to do is extract the key terms from the query for the knowledge graph using an LLM. And what I mean by that is, again, let's go back to our ontology file. We identified a bunch of different entities here, right? The key thing, though, is we need to pull the right data from the knowledge graph to help best answer our question. So in order to do that, we actually use an LLM, or here's the prompt. So it's just, you're an expert at mapping natural language to database search. I honestly didn't put that much time into this prompt, by the way. Your task is to identify key phrases in the user's question and determine the single best keyword to use for a broad case instance that contains database search. Okay, so we're going to include the actual entities from the graph for context. So again, that's from our ontology file. these entities right here, right? And we're going to give it the user the question, and here are the instructions. Read the user's question, identify phrases that refer to the entities in the graph. For each phrase, determine the most likely canonical entity type, service, contract, etc. Determine the single best keyword for contained search. This often includes abbreviations or core terms. Search engine optimization should become SEO, and non-disclosure agreement should become NDA, shit like that. So what's going to happen is, say we ask it which clients do we do a search engine optimization for. What's going to return is the keyword SEO, and the type of entity will be service, right? And similarly enough with an NDA, similar shit. It's like, okay, the contract type, it's gonna understand the type of entity will be contract for what they're asking, and it's gonna pull NDA. Essentially, if you're not super technical, all you need to know is that in this step, we're extracting the key items that the user is looking for to help best answer its question, okay, from the knowledge graph. And after we extract those key terms, we're gonna generate a query for a knowledge graph. To actually pull the data from the knowledge graph, it's called a cipher. So what we do is we get those key terms, we use an LLM to actually generate the query for it. And so in the last example, we asked which clients do we do SEO work for. Here was the generated query to actually get the context. So we get matchback client signs the documents that includes the services, where the name of the service has to contain SEO, essentially, okay? So essentially what this cipher is doing is matching back every single client that actually has an SEO node attached to it. From there on, we retrieve the answer from the knowledge graph, and that's just running that cipher that I showed right here. And we convert the raw response from the knowledge graph into a human answer just using LLMs. And by the way, this step, and this step is all using LLMs. And yeah, guys, just for the sake of this video, I'll show you guys the other question too, like which contracts do we do PPC for? And I specifically made it where only one client we did it for. Similar structure, it matches back the contracts that includes the services, where the service name has to include PPC. And again, I want to emphasize too that knowledge graphs are just a nice, easy way to pull information across numerous contracts quickly. But it's not going to be perfect. It's not going to be probably the most accurate thing in the world. But again, it just depends on your use case and the amount of error you're allowing in your AI system. Because let's say like this was more so for a legal team. Again, so probably for contracts, this probably may not be the best use case. But let's say this is like more for like a legal team. I probably wouldn't use knowledge graphs because they can get kind of iffy, because it just depends on how well we flesh out the ontology file to best capture all the relationships. Especially with knowledge graphs, there is a lot less room for error, especially when we're generating these ciphers, right? Because the matchback for SEO could maybe say just contain search engine optimization, and it may not match back to the actual SEO. Nonetheless, I do think knowledge graphs are a good way to be able to resemble interactions across different entities of data, okay? But yeah, guys, that is pretty much the end of this video. I hope you guys enjoyed it, and thank you guys so much.